Welcome to ScriptHammer. Build a Next.js app from template on ScriptHammer. In this episode, we'll cover 8 sections over about 45 minutes. What is ScriptHammer? ScriptHammer is an open-source Next.js project template built by TurtleWolf. It's a starting point for real web apps. Templates matter because nobody should start from zero. Skip the boilerplate and focus on building your features. Out of the box you get routing, TypeScript, Tailwind CSS, component structure, and development tooling. The live site at scripthammer.com shows what you can build with this template. A full SaaS platform. ScriptHammer has 45 plus features across 8 categories. Foundation, auth, core, enhancements, integrations, polish, testing, and payments. It's built with Next.js 15 and React 19. The latest stable versions with server components and server actions. Supabase provides the back-end. PostgreSQL database, authentication, row-level security, and real-time subscriptions. The project uses AI-assisted development. 27 terminals with console governance making architectural decisions. This walkthrough takes you from forking the repo to having a running customized app. Whether you're building a portfolio, a SaaS product, or learning Next.js, ScriptHammer gives you a solid foundation. Fork and clone. Go to github.com/tortoisewolf/scripthammer. That's the main repository. Click the fork button in the upper right. This creates your own copy under your GitHub account. Star the repo while you're there. It helps other developers find it and shows the project is useful. Clone your fork to your local machine. Git clone https://github.com/your-username/scripthammer.git. Install dependencies with npm install. This pulls down all the packages defined in package.json. Run npm run dev to start the development server. Next.js will show you a local URL, usually localhost 3000. Open that URL in your browser and you have a running Next.js app that was 3 commands from 0 to running. Check the README for any environment variables you need to set. Supabase keys, API endpoints, and feature flags. Project structure. The app/directory is where your page is live. Next.js uses file system routing, so the folder structure is your URL structure. App/page.tsx is the homepage. App/about/page.tsx becomes the /about route automatically. App/layout.tsx wraps every page. Navigation, footer, providers, and global styles go here. Components/holds reusable UI pieces. Buttons, cards, forms, and modals that are used across multiple pages. Lib/ contains utility functions and configuration. Database clients, auth helpers, and type definitions. Public/serves static files like images and fonts. Anything here is available at the root URL path. Styles/holds Tailwind CSS configuration and any global styles. Most styling is done with Tailwind utility classes. Config files in the root. Next.config.js for Next.js settings, sconfig.json for TypeScript, and tailwind.config.ts for theme. Supabase/ contains database migrations. SQL files that set up tables, policies, and triggers. Understanding this structure is key. Once you know where things live, navigating any Next.js project becomes easy. Customize the template. Start with the hero section on the home page. Open app/page.tsx and change the heading and description text. Swap the colors by editing tailwind.config.ts. ScriptHammer uses a theme system with named color tokens. Tailwind CSS lets you style with utility classes. Class name equals bgblue 500 text white p4 rounded right in your JSX. Add a new page by creating a folder with a page.tsx. App/dashboard/page.tsx gives you a /dashboard route. Components are just React functions that return JSX. Create components/mycard.tsx and import it anywhere. Use the existing component patterns as templates. Copy a working component, rename it, and modify the content. Environment variables go in .env.local. This file is git ignored so your secrets stay local. Check the storybook setup. npm run storybook shows you all available components in an interactive catalog. Test your changes with npm run devnext.js has fast refresh that updates the browser without a full reload. Commit early and often. Small commits make it easy to undo mistakes and track your progress. Supabase integration. Supabase is an open-source Firebase alternative built on PostgreSQL. It gives you a database, auth, and real-time out of the box. ScriptHammer connects to Supabase through the @supabase/supabase.js client. Configured in lib/supabase.ts. Authentication is built in. Email and password, magic links, OAuth with Google and GitHub, and all handled by Supabase. Author row-level security means the database enforces who can read and write data. Even if your API has a bug, unauthorized users can't access other people's data. Migrations in the Supabase/folder define your schema. Tables, columns, indexes, and RLS policies. Run npx supabase db push to apply migrations to your database. Or npx supabase migration new to create a new one. TypeScript types are generated from your database schema. npx supabase gen types TypeScript keeps your code in sync. Real-time subscriptions let you build collaborative features. Listen for database changes and update the UI instantly. The free tier is generous. 500 megabytes database, 50,000 monthly active users, and unlimited API requests. Set your next_public_supabase_ URL and next_public_supabase_ and _key in .env.local to connect. AI-assisted development. ScriptHammer uses AI-assisted development at scale. 27 terminals orchestrated by a council governance system. The council has 7 specialist roles: CTO, product owner, architect, UX designer, toolsmith, security, and DevOps. 19 contributor terminals handle implementation, each focused on a specific domain like database, testing, or components. 1 operator terminal manages the whole system, routing tasks, reviewing output, and maintaining continuity. Decisions go through an RFC process: draft, proposed, review, voting, and decided. With 9 decision records so far. 68 audit files were produced in 2 days. Wireframe validation, security reviews, and consistency checks. SpecKit provides 12/commands for specification-driven development. /specify, /plan, /implement, and /analyze. This isn't AI replacing developers. It's AI multiplying one developer into an entire engineering organization. The governance model prevents AI hallucination at scale. Council members check each other's work. You don't need this setup to use ScriptHammer. But understanding it shows how modern AI-first development works. Deploy to production. Vercel is the easiest way to deploy Next.js. The company that builds Next.js also runs the hosting platform. Connect your GitHub repo. Vercel auto deploys on every push to main, preview deploys on pull requests. Set your environment variables in the Vercel dashboard. Supabase URL, API keys, and any other secrets. Vercel's free tier includes unlimited personal projects, custom domains, HTTPS, CDN, and serverless functions. For Docker deployment, add output, standalone to next.config.js. This creates a self-contained build. The standalone output copies only the files needed for production. Much smaller than the full node_modules. Docker Compose works great for self-hosting. Define your app service, connect to Supabase, and add a reverse proxy. GitHub Actions can automate your deploy pipeline. Run tests, build, deploy, and all triggered by a push or PR merge. Set up a staging environment first. Deploy to a preview URL, test everything, and then promote to production. Monitor your deployed app. Vercel Analytics shows performance, Supabase Dashboard shows database health. What's next? You now have a running, customized Next.js app deployed to production. Add game components. ScriptHammer includes dice roller, character sheet, initiative tracker, map grid, and chat panel specs. Build a portfolio by swapping content and adding your projects. The component library handles layout and styling. Contribute back. Find an issue on GitHub, create a branch, submit a PR, and get your name as a contributor. Future episodes will deep dive into individual features. Authentication flows, database design, and payment integration. Join the community. Star the repo, watch for updates, and share what you build. All the code from this episode is on GitHub. Fork it, break it, and make it yours. Check out scripthammer.com for the latest features and documentation. Welcome to ScriptHammer, Auth payments on ScriptHammer. In this episode, we'll cover 8 sections over about 30 minutes. Let's get started. Authentication overview. Every SaaS app needs authentication. Who are you, what can you do, and how do we prove it? ScriptHammer uses Supabase Auth as its identity provider. Sign up, login, sessions, and token refresh out of the box. 3 sign-in methods are configured. Email and password, OAuth with Google and GitHub, and Magic Link via email. JWTs, JSON Web Tokens, carry the user's identity. Supabase issues them on login and your app sends them with every request. The Anon key is safe to expose in client code. It only grants access that your row-level security policies allow. The service role key is the admin key. It bypasses RLS and must never appear in client-side code or Git history. Server components in Next.js 15 can read the session cookie directly. No client-side JavaScript needed for auth checks. Understanding auth is the foundation for everything else. Protected routes, RLS, and payments all depend on knowing who the user is. Email and password flow. The most common auth method. User provides an email and password, Supabase creates an account and sends a confirmation email. Supabase.auth.signup, email, password, creates the user. By default they confirm via email before signing in. After confirmation, Supabase.auth.signin with password, email, and password, returns a session with access and refresh tokens. The access token is short-lived, 1 hour by default. The refresh token rotates it automatically so users stay logged in. ScriptHammer wraps these calls in server actions. Next.js 15 handles the round trip without client-side fetch calls. Password requirements and rate limiting are configured in the Supabase dashboard. No custom code needed. Supabase.auth.reset password for email sends a reset link. The user sets a new password on your callback page. Store nothing sensitive in your own database. Supabase manages password hashing with BCRYPT automatically. OAuth with Google and GitHub. OAuth lets users sign in with an existing account. No new password to remember, higher conversion rates. For Google, create credentials in Google Cloud Console. Copy client ID and secret into Supabase Auth provider's settings. For GitHub, register an OAuth app. The callback URL is https://your-project.supabase.co/auth/v1/callback. Supabase.auth.signin with OAuth, provider, GitHub, redirects to GitHub's consent screen and back. The user's profile data, name, avatar, and email, is available in session.user.user_metadata. Personalize the UI immediately. Account linking happens automatically. Signing up with email then later using Google OAuth with the same email merges the accounts. Test OAuth locally by setting redirect URLs to http://localhost 3000 in both Supabase and the provider console. Keep OAuth secrets in environment variables. Never encode, never engit. Magic link authentication. Magic links are the passwordless option. User enters their email, clicks a link in their inbox, and they're in. Supabase.auth. Sign in with OTP, email, sends a one-time login link that expires after 1 hour. No password to forget, no password to store, and no password to breach. The email itself is the authentication factor. When the user clicks the link, they land on your /auth/callback route, which exchanges the token for a session. Magic links work well for low-friction signups, blog subscribers, beta testers, and event registrations. The downside is dependency on email delivery. Slow emails or spam filters block the user entirely. Rate limiting is built in. Supabase limits OTP sends to prevent abuse on your email quota. Combine magic links with OAuth. Let users choose their preferred method on the login page. Protected routes and middleware. Not every page should be public. Dashboards, settings, and payment pages require authentication. Next.js middleware runs before every request. It checks for a valid session and redirects unauthenticated users. Supabase.auth.getUser is the server-side check. It verifies the JWT and returns the user or null. If there's no user and the route is protected, redirect to /login with the original URL as a return parameter. Public routes like the landing page, docs, and pricing are excluded using the route matcher in middleware.ts. Server components can also check auth inline. Await supabase.auth.getUser at the top of any page. Client components use a session hook for real-time UI updates. Show hide elements based on auth state. Always check auth server-side even if you also check client-side. Client checks are for UX, server checks are for security. Row-level security policies. Row-level security is PostgreSQL's built-in access control. Even if your API has a bug, unauthorized data stays hidden. RLS policies are SQL rules on tables. They filter which rows a user can select, insert, update, or delete. A basic read policy. Using auth.uid equals user_ID means users can only see rows where their ID matches. Auth.uid is a Supabase helper that extracts the user ID from the JWT. Available in every policy expression. Write policies use with check. Prevents inserting or updating rows that belong to other users. Public data gets a permissive policy. Using true on select lets everyone read while writes stay restricted. RLS policies can reference subscription status. Using subscription_tier equals pro restricts premium features at the database level. Test your policies by signing in as different users. The Supabase Dashboard SQL Editor also lets you test RLS directly. Stripe Payment Integration. ScriptHammer uses Stripe for payments. Credit cards, subscriptions, invoices, and tax compliance handled externally. The flow has two parts. A client-side checkout session that redirects to Stripe, and server-side webhooks that confirm payment. Stripe.checkout.sessions.create builds a checkout URL. You specify the price ID, success URL, and cancel URL. Stripe's hosted checkout handles PCI compliance. Your server never touches credit card numbers. Products and prices are defined in the Stripe dashboard. Each price has a price_ID that your code references. Environment variables. Stripe_secret_key for API calls, Stripe_webhook_secret for verifying webhook signatures. After payment, Stripe redirects to your success page. But don't grant access based on the redirect alone. The redirect is UX, the webhook is the source of truth, because Stripe signs it and sends it server to server. Subscription tiers and webhooks. ScriptHammer defines tiers in Stripe. Free, Pro, and Team. Each with different feature access enforced by RLS. Webhooks are how Stripe tells your app what happened. Payment succeeded, subscription cancelled, and invoice failed. Your webhook endpoint verifies the signature with stripe_webhook_secret. Prevents anyone from faking payment events. Checkout.session.completed fires after payment. Update the user's subscription tier in your database. Invoice.payment_failed means a renewal was declined. Notify the user and give them a grace period. Store the Stripe customer ID and subscription ID in your profiles table. Link to the Supabase user ID. Always handle webhooks idempotently. Stripe may send the same event more than once, so check before processing. The full flow. User clicks subscribe, API creates checkout session, Stripe handles payment, webhook confirms, database updates, and RLS enforces. Welcome to ScriptHammer, AI orchestration on ScriptHammer. In this episode, we'll cover 8 sections over about 30 minutes. Let's get started. Why AI orchestration? A single AI terminal can write code, but it can't review its own work, plan architecture, and check for security holes at the same time. ScriptHammer uses 27 AI terminals working in parallel. Specialization produces better results than one terminal doing everything. Think of it like a real engineering team. You wouldn't ask the same person to design the database, write the front end, and review security. The core insight is cognitive load splitting. Each terminal has a narrow focus and a short system prompt tailored to its role. Without orchestration, AI output drifts. The model invents features nobody asked for, forgets constraints, or contradicts itself. Orchestration adds accountability. Every decision has a paper trail showing who proposed it, who reviewed it, and who approved it. ScriptHammer produced 68 audit files in 2 days using this system. Wireframe validation, security reviews, and consistency checks. Solo developers benefit the most. AI orchestration lets one person operate like an entire engineering organization. The 27 terminal architecture. 3 tiers. 7 council members make decisions, 19 contributors implement features, and 1 operator, Turtlewolf, manages everything. Council members review proposals, vote on RFCs, and set standards. They're the architects and reviewers. Contributors handle implementation. Each one owns a specific domain like database, components, auth, or testing. The operator routes tasks, reviews output, resolves conflicts, and maintains session continuity across all terminals. Each terminal runs with a scoped system prompt. The database contributor doesn't see front-end instructions and vice versa. Scoped prompts keep context windows small. A focused 5K prompt produces better results than a 50K prompt covering everything. Terminals communicate through shared files. RFCs, decision records, audit logs, and handoff primers in known directories. The file system is the message bus. No custom IPC, no WebSocket relay, and just markdown files. This scales horizontally. Adding a contributor means creating a new terminal with a new prompt, no code changes. Console governance. 7 specialist roles. The CTO sets technical direction. Technology choices, performance budgets, and technical debt prioritization. The product owner defines what gets built. User stories, feature prioritization, and scope control. The architect designs system structure. Data models, API contracts, component hierarchies, and dependency boundaries. The UX designer owns user experience. Wireframes, interaction patterns, accessibility, and design system consistency. The toolsmith builds developer tooling. SpecKit commands, automation scripts, and CI/CD configuration. Security reviews for vulnerabilities. Auth flows, input validation, dependency audits, and RLS policy correctness. DevOps handles infrastructure. Docker config, deployment pipelines, monitoring, and environment management. Each role has domain authority. Security can veto a feature that introduces vulnerabilities, even if product owner prioritized it. Council members check each other's work. The architect proposes a schema, security reviews for data exposure, and DevOps checks deployability. This cross-checking prevents hallucination at scale. No single terminal's output goes unreviewed. RFC decision process. RFC stands for Request for Comments. A formal proposal moving through draft, proposed, review, voting, and decided. Any terminal can write a draft. A contributor working on auth might propose a new session management strategy. Moving from draft to proposed requires motivation, detailed design, alternatives considered, and migration path. Council members weigh in during review. Commenting, asking questions, requesting changes, or approving. Voting requires a quorum. At least 4 of 7 council members participate, simple majority decides. ScriptHammer has 9 decision records so far. Each documents what was decided, why, and what alternatives were rejected. Decision records are immutable. Once decided, they don't get edited. New RFCs can supersede old decisions. The overhead is minutes per decision, not hours. AI terminals write and review RFCs fast when the template is clear. SpecKit/commands. SpecKit is the specification-driven workflow. 12/commands that turn ideas into implemented, tested features. /specify generates a detailed feature spec. Inputs, outputs, edge cases, acceptance criteria, and schema changes. /plan breaks a spec into implementation tasks. Ordered by dependency, each with estimated effort and assigned terminal. /implement executes a plan task. The contributor writes code following the specification exactly. /test generates test cases from a specification. Unit, integration, and E2E scenarios. /review runs a code review checklist. Style, security, performance, and accessibility. /audit produces a formal audit file. Security review, wireframe validation, or consistency check. /handoff generates session continuity primers. What's done, what's in progress, and what's blocked. The remaining commands. /analyze reviews existing code, /status shows progress, /broadcast updates all terminals, and /validate checks against spec. Each command has a structured output format. No freeform AI rambling, just consistent actionable documents. Memo routing mixture of experts. Not every terminal needs to see every message. Memo routing sends information only to terminals that need it. Inspired by the mixture of experts pattern in ML, a gating function decides which expert handles each input. When a contributor finishes a task, the result routes to relevant council members. A database change goes to security and architect, and not UX designer. The operator acts as the gating function. Scanning output and deciding who needs to review it. Routing reduces noise. The toolsmith doesn't need every component implementation. The UX designer doesn't need every migration. Broadcasting is the exception. Decided RFCs and breaking changes go to everyone. Memos are markdown files with A2 header. Simple, readable, and no custom tooling required. Without routing, every terminal's context fills with irrelevant information. Quality degrades as sessions get longer. Session continuity handoff primers. AI terminals don't have persistent memory. Every new session starts from 0 unless you give it context. Handoff primers capture the current state. What's done, what's in progress, what's blocked, and what decisions are settled. The /handoff command generates primers automatically. Summarizing changes, open tasks, pending reviews, and known issues. A primer includes decision context. Not just what was decided, but why, and so the next session doesn't relitigate. File references are critical. The primer lists every modified file so the next session knows where to look. Primers are timestamped. Handoff-2025-01-15-1430.MD tracks project state evolution over time. The operator writes a master primer covering the whole project. Individual terminals get focused primers for their domain. This is the single biggest quality of life improvement. Sessions pick up exactly where you left off instead of starting over. Building your own AI pipeline. Start with 3 terminals, not 27. One for planning, one for implementation, and one for review. Write system prompts as markdown files. Keep each under 2K tokens for focused context. Use a shared directory for communication. Specs, decisions, and handoffs in known locations. Start with manual routing. You read output and decide who sees it. Automate later when patterns are clear. Claude Code's workflows translate directly. You may already be doing informal orchestration. The governance overhead scales with risk. A side project needs less process than a SaaS handling payments. ScriptHammer started with 5 terminals, grew to 12, and then 27 as the project demanded more specialization. The real skill isn't using AI. It's decomposing work, defining boundaries, and maintaining quality across parallel streams. Welcome to ScriptHammer, testing and deploy on ScriptHammer. In this episode, we'll cover 8 sections over about 30 minutes. Let's get started. Testing philosophy. Tests aren't about catching every bug. They're about catching the same bug twice. Once it's tested, it stays fixed. ScriptHammer uses a 3-layer strategy. Unit tests with Vitist, component tests with Storybook, and E2E tests with Playwright. Each layer catches different problems. Unit tests verify logic, component tests verify UI, and E2E tests verify user flows. The testing trophy model says integration tests give the most confidence per effort. But you need all 3 layers. Write tests as you build, not after. SpecKit/test command generates test cases from specifications before implementation. Tests are documentation. A well-named test file tells the next developer exactly what a function is supposed to do. ScriptHammer has 680 plus tests across all 3 layers. That number grew naturally as features were built. Don't chase 100% coverage. Focus on behavior that matters: auth flows, payments, data mutations, and edge cases. Unit tests with Vitist. Vitist is the test runner. Fast, TypeScript native, and compatible with the Jest API you might already know. Test files are co-located with source. lib/utils.ts has lib/utils.test.ts right next to it. The basic pattern. Describe groups related tests, it defines a case, and expect makes assertions. Mock functions with 6.fn, replace dependencies. Test a function that calls Stripe without hitting the real API. 6.mock @/lib/supabase replaces an entire module. Return whatever data your test needs without a database. Run tests with pnpm test. Vitist watches for changes and reruns affected tests automatically. pnpm test. Coverage generates a coverage report. Useful for finding untested paths, not as a target to game. Server actions need special handling. They run on the server in production but need to be testable in a node environment. Component testing with Storybook. Storybook renders components in isolation. Outside your app, outside routing, and outside data fetching. Each component gets a story file. PricingCard.stories.tsx shows every variant with different props. Stories serve double duty. Interactive documentation and the foundation for visual regression testing. Chromatic screenshots every story on every PR and highlights pixel level differences. catches unintended visual changes. Interaction tests simulate clicks, form fills, and keyboard events. Then assert on component state. The play function defines the interaction sequence. Click a button, wait for a response, and check the result. Stories are great for edge cases. What does the card look like with a 200-character title, no image, or an error state? Design handoff gets easier. The UX Designer Council terminal references storybook URLs in wireframe validation audits. E2E tests with Playwright. Playwright tests your app like a real user. Opening a browser, clicking buttons, filling forms, and navigating pages. Tests live in the E2E/directory organized by feature. E2E/auth.spec.ts, E2E/payment.spec.ts. Playwright runs in Chromium, Firefox, and WebKit. Cross-browser testing without separate test suites. Page.getByRole and Page.getByText find elements the way a screen reader would. Built-in accessibility validation. Test fixtures handle common setup. A logged-in user fixture signs in once and reuses the session. Playwright's trace viewer shows exactly what happened on failure. Screenshots, network requests, and DOM snapshots. Run PNPM Playwright test for all E2E tests or PNPM Playwright test. UI for the interactive runner. E2E tests are slow compared to unit tests. Run them in CI, not on every file save. CI/CD with GitHub Actions. GitHub Actions runs tests automatically on every push and pull request. No manual "did you run the tests" checks. The workflow file lives at .github/workflows/ci.yml. It defines the test pipeline as code. Stages run in order. Install dependencies, lint, type check with TypeScript, unit test with Vitest, and E2E test with Playwright. Caching speeds up CI. Cache node_modules based on the lock file hash, cache Playwright browsers by version. Pull request checks are required. Branch protection rules prevent merging until all CI checks pass. The CI environment needs secrets. Supabase URL and API keys stored as GitHub Actions secrets, never in the workflow file. Chromatic runs as a separate step. Capturing storybook screenshots and commenting on the PR with visual diffs. Keep CI fast. Under 5 minutes for the full pipeline. Slow CI trains developers to ignore it. Deploying to Vercel. Vercel built Next.js. Their platform is optimized for it with zero configuration needed. Connect your GitHub repo. Every push to main triggers a production deploy, pull requests get preview URLs. Preview deployments are the killer feature. Share a live URL for code review instead of "it works on my machine." Set environment variables in the Vercel dashboard. Next_public_supabase_URL, stripe_secret_key, and other secrets. Vercel handles HTTPS, CDN, serverless functions, and edge caching. You don't configure any of it. Server components and server actions run as serverless functions. They scale to 0 when idle. The free tier includes unlimited personal projects, custom domains, and 100 GB bandwidth per month. Vercel Analytics shows real user performance data. Core Web Vitals, page load times, and geographic distribution. Docker deployment option. Not everyone wants vendor lock-in. Docker lets you deploy ScriptHammer anywhere, AWS, DigitalOcean, and your own server. Add output, standalone to next.config.js. Next.js creates a self-contained build without the full node_modules. ScriptHammer's Docker file uses multi-stage builds. One stage installs and builds, the final stage copies only the output. The production image uses Node 22 Bookworm Slim. Minimal Debian base with near zero CVEs. Docker Compose defines the full stack. Next.js app, PostgreSQL, and a reverse proxy like Caddy for automatic HTTPS. Persistent data goes in named volumes. The database volume survives container restarts and redeployments. Set restart, unless stopped on every service. Your app comes back after server reboots without manual intervention. Docker deployment means you own your infrastructure. Full control over scaling, networking, and data residency. Monitoring and maintaining production. Deploying is not the finish line. Production apps need monitoring, updates, and incident response. Health check endpoints tell your infrastructure if the app is alive. /API/health returns 200 if server and database respond. Vercel provides built-in monitoring, error tracking, function logs, and real user metrics. For Docker, use Docker Compose Logs F for quick debugging or ship logs to Grafana Loki for long-term storage. Dependency updates are recurring. Run npm audit regularly and patch vulnerable packages before they become exploits. Database migrations run before deploying new code. The schema must be ready when the new version starts. Plan for rollbacks. Vercel redeploys any previous version instantly. Docker rolls back to a previous image tag. Production maintenance is ongoing. Budget time for updates, monitoring, and alerts, and not just building features.